So this is the second part of my 6.3. So base of support. So base of support refers to an area beneath an object or person that includes every point of contact that the object or person makes with the surrounding surface. You can increase or decrease this depending on how much contact is on the ground. So line of gravity is an imaginary line, as you can see in the picture, that extends vertically through the centre of gravity to the base of support when the body is balanced, and outside the base of support when the body is not balanced. So 2D and 3D imaging. So firstly, the participants, this is the method. So firstly, the participants preparation will include completing a parkour, a warm-up, and explanation of the protocols. This will prepare the participants and get them physically and emotionally ready. So then measuring the force plates, measuring the force and movement, we can use the data to calculate the linear displacement. You can use the force plates, which is around 100 times which records 100 times per second, cameras for movement, and Vicon for combination. Then so the method includes calibration of the force plates to make sure that they're safe and working, because if they aren't, the results won't be useful. Then there's 4 protocols, which are the 45-degree jump, the 90-degree jump, normal counter movement jump, and the 45-degree wide base jump. So a Googie meter, as you can see in the picture, can be used to measure the joint angle to make sure that they're actually jumping what the protocol states in the angle. The scale measures on the ground reaction force, therefore we need to make sure that the athlete takes off and lands on the plates. Practice jumps could be helpful. So digital imaging. So where the camera is set up, filming is crucial for getting accurate results. The camera needs to be perpendicular to the performer, the correct angle to get the whole person in, and the correct angle. There are 4 camera settings, which are sampling frequency, shutter speed, focus, and iris. Sampling frequency is the frame rate and the number of individual frames that comprises your video per second. Super slow-mo is a high-speed camera. To look at an angle changes, you need a high frame rate and frequency to capture more detail. The shutter speed gives a clear footage, and detailed angles means the higher the frame rate. The shutter speed is the time taken to take each picture and how long each frame is captured for. The speed at which it takes each picture will allow less time to get in, so the picture is clear. For this, the camera should be level to what you are measuring, and the gap in between the view is called the triangulation. Other camera settings are the focus, which is manual automatic, the lens, which zooms, and iris, which is how wide the aperture opens. Things to consider when positioning the camera is the planes of motion, the distance of the person, the field of view capturing the entire motion of the action, and the image size. So you can use a meter rule for vertical referencing at the starting point to make sure the correct distance from the person. So the physical camera setup to be triangular, tilt, pan, or roll to get the best position for the correct results. Different planes are complicated to capture as well, as these are sagittal, frontal, and transverse are the axis of rotation, and the axis of rotation for each are transverse for sagittal, vertical for frontal, and sagittal for transverse. An example of this: when doing a spin move in basketball, the axis is vertical and the plane of motion is transverse. So the principle of recording is to maximize the image size within the field of view, to be aware of the action has motion. Having a different view of the same thing is perspective error, and a parallel error is looking from different levels where you can see different angles. Therefore, you need to check where your eye level is, and this should be the same height straight on. So finally, the method does have implications including poor data collection methods, poor footage, poor data analysis, and therefore false conclusions. So this is the data we got from the test. We collected from the numerical model, which we'll be analysing in 6.4.